Okay, so now the session is being recorded. So I just wanted to put this first so that you remember when at the test. So this is that, and then just to verify, I'm gonna send the assignment 1 today, but let me just verify when is it due. It's due on the, here I return 708, but I think we can do it a week after that so that it can be safe. So 7, so let's say an assignment 1, due date will be 14/08/2026. Yeah. So I will change it on there. So let's just put 14 there instead of 7. Yeah, so it will be due on the 14th. So therefore, that will be the time that you will submit the assignment. Then remember, it's supposed to be in groups, 8 to 10 people, so that to be able to mark it nicely. Then remember, you will have to present it. Your work. So we'll say on the 14th, you have the whole day. Then we will allocate time for each group, and then we just tell you the group 1 to group 4 come between this time and this time, but we'll do that when time comes. For now, then, we can start with our class. So we're in chapter 1. So we'll start over from everything from yesterday. So we are starting with chapter 2, estimation of the population mean. But the most important thing will be that sigma is no. Then the question will be, what does it mean when we say sigma is known? It means that the population standard deviation is given. That's what it means. And then what does that mean? Then it means that we always use normal distribution. We always use normal distribution when it is given. Normal distribution then means that it's a Z. So Z will always stand for normal distribution. Always remember that. And then that takes us to the formula, which would then be X plus minus Z alpha over 2 sigma over square root of N will be that. So now this means that it's a normal. This one. This means that this is a normal distribution. In this formula, this is the only thing that shows that whatever formula that you are using is a normal distribution. This we already know that this is the sample mean, so let's just call it a sample mean from first semester, which we know that to calculate it is X bar is equals to sum of X over N, meaning that we add them and divide by their total number. And then this part here will be population standard deviation. This will always be given in the question, because when it is given, it is what then determines whether you are using normal distribution or not. If it's given, you know that you are using normal distribution. If it's not given, you know that we are not going to use normal distribution, but that will be the next part. Then this will be the same as first semester, which is the sample size, meaning that total number of X values, meaning that let's add them and get the total. Then this will be the population mean. When I first met first semester, I told you that you will never be asked to calculate the population mean. So this will always stay in the formula. So that we can then see our job today is to always estimate. So let's write this in red. Our job is to estimate the population mean, which is mu, using a sample mean, which is X bar. What this means is that once we get the value of X bar, then we have estimated the value of what? Of mu. Then this takes you to what we call point estimate of the population mean. So let's just say point estimate of mu. We know that wherever you see mu, this means that population mean. So in a question, I can use the value or I can use the words. They still mean the same thing. So we know that the point estimate of mu will always be equals to X bar, meaning that mu will always be estimated by X bar. So whenever in a question I say, what is the point estimate of this? I want the value of that. So we're gonna use the value, now the value of X bar to estimate the value of what? Of mu. Always remember that when it comes to that. So then the question will just be in the simplest term, point estimate of mu is equals to X bar. So therefore, when I asked it in a question, then you always know what does that mean. Then this, now that we know that it's supposed to be a normal distribution, and then we know what is the X bar. Now, just to make sure that we understand why it's supposed to be a normal distribution. So this, I don't care about this. I'm going to show you a better way for that. But let's read example number 1. So a random sample of 90 chefs. So meaning that, let's put that so that we can write on it. A random sample of 90. So this means that N is equals to 90. The sample number of the hours worked per week was found to be sample number of the what? Sample number, a random sample number of hours worked per week was 61 on average. So this will be X bar. So that's the mean. Assume a population standard deviation of UC. Assume a population standard deviation of that. That will be sigma. Then that answers the question, is the population standard deviation given or not? You see, it is given. So therefore, because it's given, we have to use normal distribution. And then now, the question says find 99% confidence interval. Yesterday we did the 99%, but we'll do it again here. So now, this verifies that, like this then tells you what do we actually mean when we say the population standard deviation is given. It means that when you read a question, it is there, it is given there. Now, this takes us to so that we can just remember what we used to do. So let's go through the normal distribution table. So the normal distribution table, the most important thing is to know what is alpha. And now the formula for finding alpha will be 1 minus alpha multiplied by 100% multiplied by CI. CI means confidence interval to be given in each question, you see. Find 99% confidence interval, CI. So it's 99%. So it will always be given in a question. Then in this case, we are saying CI is equals to 99%. Then for example, 1 minus alpha 100% equals to 99%. This would then be 99% over what? 100%. This will be 0.99. 0.99. And then if it's 0.99, then negative alpha will be 0.99 minus 1, which will be negative alpha 0.01 negative. Then alpha is equal to 0.01. We divide by negative. Let's just do that. Negative 1. Negative 1, that alpha 0.01. Now, the thing is, you can never leave alpha at 0.01 for a reason, because our formula says alpha divided by 2. Meaning that whichever alpha that you find, it needs to always be divided by 2. In this case, what we need to have at the end is alpha divided by 2, which is 0.01 over 2. Then this becomes 0.05. We're not looking for that one. Always remember that. We're looking for alpha divided by 2 in terms of chapter 1. Now that we know what is our alpha, now let's learn how to read the table. So now, in terms of the table, if you go back to first semester, I give you Z equals to 1.96. We look for 1.9 in the left side, 6 at the top, but that you remember. So if we say negative, so this was going to be negative 1.9, 6 at the top with the mid. So now I'm giving you the 0.025 and say, give me what is the Z. And then I say, give me the Z. So now if you go back to our example, does this one right? Okay. So now if you go back to our example, we have alpha divided by 2 as 0.005, like that. And then what I said yesterday in class is this. So the best thing is to look for rows. So now we start with this. So this, we look for it inside, not outside. So if we're looking for 0.05, it's simple. Let's start. Let's come inside here. Tell me where all the rows where we have a 0, 2 zeros after the comma. Where do I end? Anyone can stop. So it starts from here where we have 2 zeros after the comma until number what? Until what?
Negative 2,4.
Until negative 2,4. That means that the rest of the tables, our values cannot be there. Do I agree? Now, what is the value after the 2 zeros? We have a 5. Now, we want a row where after 2 zeros we have a 5. Which row is that? Remember, now we have the 2 zeros. Now we have a 5. Which row where after 2 zeros you have a 5? Which row is that in the screen? It's which row?
-2.
So that will be the row. Then which means that the value that we're looking for is in that row. So all the rows no longer matter now. Now, in the row that we are in, I would say, give me where is now this value is between two values. Is between which and which value? It's between the value in number, let's put this there. It's between the value in 7 and the value in 8. Do we agree?
Yes.
That 0.05 is between those. 0.005 is between, it's here, it's between the two values. Now, once we do that, the only question that we need to ask ourselves is that between the two values, which one is closest to our value? That should be simple. We say the values that we want. So we say the value we want minus the two values. So this first one will be 0.0508, which will give you 0.12348. The second one will be 0.005 minus 0.00494, which will give you 0.00006. Now this question is simple. Between the two values, which one is the lowest? Mofe, you have a hand up, you can speak.
I'm sorry, sir, but I'm having an issue. I'm not understanding how we find the 0.05. I'm trying to move with you, but it seems like my network, when you point something, it takes time for me to see where you did. Can you please repeat?
Okay, let's start over, man. I'm not worried about that. So we'll remove that. So now the question is, we're looking for 0.05. 0.005. If we look at our value, all the values inside there are 0, something, 0, something. Always remember that part. That all the values inside there are 0, something, 0, something, 0, something. Now, since we're looking for 0.05, the question is simple. We need to look for it in the two tables, the one for negative and the one for positive. As you can see, the one for positive, it starts from what? 0.5. Any value above 0.5, you can find it in the positive. Any values below 0.5, we have to find it in this one. Now, the question is simple. Inside, I want all the rows where they have 2 zeros, at least 2 zeros after the comma. The lady said that from 3.9 to 2.5 to 2.4, let's just include let's just include 2.3 up until 2.3. Up until 2.3. Those are the only rows where after the comma, we have 2 zeros, and we agree with that. Now the question is, from what we're looking for after the 2 zeros, what are we looking for? We are looking for 5. Now I want a row where it has 2 zeros, and after the 2 zeros, you have a 5. Then the lady said that can only be seen in 2.5. You have to agree with that. Only in 2.5, where after the 2 zeros, we have a 5. You see, we have a 5, we have a 5, we have a 5, 5, 5, 5. Now the question is simple. Since we know the row, in this row, go where our value is between the two values. Our value is supposed to be between two values. It's either is there exactly or it's between two values. And we're agreeing that it is between these two values. This one. Our value is between those two values. which is 0.005. So now it's very simple. We need to find the one which is closest to the value that we're looking for, so that we know which one is our value closest to. The same way that, like I gave example yesterday in class. So if I say I want the person whose age is closest to my age, we say it is very simple. I just say everyone in this class minus I say my age minus the age of everyone in this class. And the one with the lowest difference will be the one who's closest to me. The same way we are looking for 0.05. So we use this method. We say the value that we're looking for minus the two values. Then we have the answers, the first answer, second answer. Now the question is, out of the two values, which one is the closest to the value that we're looking for? Like, which one is the smallest out of the two values? Is this one. So therefore, for alpha divided by, so if we say, write it nicely. So now for z, alpha divided by 2, which is the same as z, 0.005, the answer is 2.58. Why 2.58? We are at 2.5. The one that gives us a smallest value is this one. So where it is at 8, so we have negative 2.58. I said whenever we do this, I don't want the negative. So the answer should always be positive. So it's like that. We can just do another example to make sure that we get it. But for this, we can then say z alpha divided by 2 is equals to z at 0.005, which is 2.58. Now let's say Ci is equals to 80%. If it's 80%, what will be alpha? So you can do this one in your book. What will be? So let's replace 99 with 80%. What will be the answer? What will be alpha? Not alpha divided by 2 first. What will be alpha? Anyone can speak?
Zero comma one.
No, not alpha divided by 2. Just alpha. What will be alpha? Before we divide by 2.
Zero comma two.
So it will be like that. Alpha will be 0.2. Then alpha divided by 2 will be 0.2 divided by 2, which is 0.1. So what we're looking for is z alpha divided by 2, which is z equals to 0.1. 0.1. Then what is the answer? It's very simple. We go back to our table. Let's rub the rest. So the only question is, what are we looking for? We're looking for alpha divided by 2, which will be 0.1. So now it's very simple. In this inside here, we want the rows where after the 0, after the comma, we have 1. Which row is that? Which row? Or the rows? You can give me all of them, it's fine. We start from what to what? Where after the 0?
2.3.
1,2 to negative 0,9 to negative 1,2.
So we are there. But then can you notice that they are in order? Here, this from the smallest, going that side, coming back to the highest here. Can you see that? Starting here. This is the smallest. Can you see that? Because now it means that the value that we're looking for after the comma. So now, if it's that is the same as 0.10. Can we agree?
Yes.
That's 0.1. Okay, now I want to weigh after the one, this is 0. That can only be found in which row? After one where this is 0, that can only be found in row number what?
Negative 1,2. 1,2.
So you see, that's the only row that we're interested in. We're only interested in row negative 1,2. Now, go find me the two values where our values between them. Our values between which value and which value, two value in that row. So it is easy. You don't have to read this one. You can tell me the ones at the top. Or it's between 7 and 8, 5 and 6. What? What is it between? 8 and?
9.
So the value that we're looking for is between 8 and 9. So it's between those two values. Now we do what we do. So 0.1, this is the value that we're looking for, minus 0.10027. What will be the answer? Give me the answer for that.
Negative 0,00027.
Like that, ne? The negative doesn't matter. Whether it's negative or positive, it doesn't matter when you take the difference. Then the next one is 0.09853. And then this one, what is the difference? 53?
0,00147.
Like that. Now, out of the two, which one is the smallest? The first one or the second one?
The first one.
This is the lowest, where we find it at 8. So we know that we have 1.2. At the top, we have 8. So then alpha at 0.1, the answer is 1,2. So then we know that in this case, the answer will be 1,2. Any questions? Okay. So if the answer is 1,28, therefore, let's say confidence intervals. So let's say 95%, 97%, 99%. I can ask you any of those things. 96%. I can ask you any of these values. 90%. Your job is to then go and make sure that you understand how to find for 95, for 97, 99, 80, 96, 90. So this should be 1.96. I don't know this one. 99, 0.005. We did 2.58. This one should be 1.64. I don't know this one. This one we just did it is 1.28. So now your job is to then understand this part, understand how to get. So when given this, you understand how to find alpha, then alpha divided by 2. Then you understand how to find z at alpha divided by 2. You see this procedure. No mark will be given from jumping from getting alpha to the final answer. I need to see how you got the first answer first. You show me how you got alpha divided by 2. I'll give a mark for alpha divided by 2 and a mark for z alpha divided by 2. Always remember that. So now this takes us to the question, to the formula. Now, if you go back, I want you to write down this. So if you go back to the example, we have said n, it's 90. So write n is equals to 90. Then we said x bar is equals to 63,1. So x bar is 63,1. Then we say assume that the population standard deviation of what? Assume a standard deviation of 8,8. 8,8. That just answers a simple question. Is the population standard deviation given or not given? It's given. Then write down the 99%. So we also have 99. So you have the three values. You have n, x bar, sigma, ci. Did you write that down? Did you write it down? Okay.
Yes.
So now, this just say we say example 1. With example 1, n is given as 90. What is x bar?
63,1.
What is sigma?
8.8.
Ci is 29%. This is how we answer the question. So now, this I will write it down in the memorandum. Every memorandum you see, I will have this first. I will say given. Then I'll say solution. First thing before you write anything is to write down the formula. Remember, you'll be copying it, so you won't have a problem with writing it down first. Then now, we say the first letter, do we have it? We have it. Second letter, do we have it? That's the thing that we don't have. So now, we say zeta alpha divided by 2 is what we don't have. Ci is 99%. We already done that, so we know that alpha is 0.01. Alpha divided by 2 is 0.005. Z alpha divided by 2 is Z 0.005, which we said is 2.58. Now, sigma, we'll go to the next letter. Sigma, that's given. N is given. It doesn't need to be given. So this takes us to x bar. If we're rewriting the formula, so x bar, we know that is 63,1 plus minus 2,58 multiplied by 8,8 over square root of 90 mu. Then now the question is, what do we do here? So this is what I want. Now we say 63,1, we use the minus first. Remember, when I say 99% confidence interval means that we're supposed to have two values. So we are going to have a value for negative and a value for positive. Now the question is, how do you write interval? Interval should always be from the smallest to the highest, meaning that the first value is supposed to be for negative. So now, this is what we do. Say 63,1 minus everything here, and it give me the answer. So we're starting with 63,1 minus 2,58 multiplied by 8,8 over square root of 90. What is the answer?
Sig is 2,71.
Give me one by one. So it's
60,71.
71. Now, once you do the negative, now you just go back to your calculator, remove the negative and put positive. That's the only thing that changed. Remove the negative and put the positive. What is the answer?
65,49.
This means that our value is between this. So we can make a conclusion and then we can say, we conclude that what is in the conclusion? What is the question? Someone have their mic on. It's making it. So we conclude that percent of confident interval for the population mean. We just answer the question. The population mean is between 60,71 and 65,49. So this means that when we estimate our mean, our population mean is between these two values. Always remember that. Now, once you know the formula, we have something that we call margin of error, which will always be given by E, by a letter E. What this means is that so once we have this formula, what is the only thing that affects the value of X bar? The things that affects, that increase or decrease the value of X bar is this. Now, that is the only thing that decide what X bar we're going to have. And this is what we call margin of error, which then this will mean margin of error, which is given by E, will always be Z alpha divided by 2 sigma over square root of N. Meaning that if we go to our case, for example 1, if you go to example 1, then E will be Z alpha divided by 2 sigma over square root of N to be 2,58, not 8. 2,58 multiplied by 8,8 over square root of 90. What will be the answer?
2,39.
2,39. This means that in our formula, the 2,39 is the one that we're going to minus or add. So meaning that that's the thing that affects the margin of error. Always remember that. Whether this value with the value, whether this value increases or decreases, how much it increases or how much it decreases by, that can only be affected by what we call a margin of error. Now, for every formula that we're still going to have, I want you to understand the margin of error as the part between plus, minus, and less than or equals to. Are we together there? E, in every formula that we're going to see, so we're going to have plus, minus. I'll put something there and I say less or equals to. Whatever that I put between plus, minus, and less or equals to, that will always be what we call the margin of error. Now let's see what are the conditions that we need to have to always use the formula this formula. If you look in your notes, we have case 1 and case 1. I don't want those one. So we will only use normal distribution only when population standard deviation is given. How together we only use the normal distribution, or when I say normal distribution, this is the formula that I mean. This formula can only be used when the population standard deviation is given. Always remember that. Now, that would then takes us to the next part. So if you read the example, Discard. So read example number 2. You see here where it's right sample standard deviation. I will always be specific that is a population, not a sample. Always remember that. Ne? I will together. So this example, if it comes in the test, here I will change to population standard deviation. I won't say this one of sample, so that whether use case 1 or case 2, it's fine. So forget about the case 1 or case 2. I will then say the population standard deviation. Always remember that. And then we have the last part. Okay, we're still at 8 minutes, so we can do the next part. So now we have what we call, using the same formula, determine the sample size. Sample size, we know that's n. So let's say you are not given n, but you are given everything else. Now, this is where the margin of error comes in. So we have E is equals to Z alpha over 2 sigma over square root of n. So let's say you are given E, you know how to find Z, you are given sigma. Now what we want is n. Then the only thing it will be to make n the subject of the formula. Previously, I would try to make you, what do we call this? To derive the formula, but no longer. So if you ever write SAP or especially special exam, I will make you derive the formula. For now, we just have to know that n would then be given by Z alpha divided by 2 squared sigma squared over E squared, which then this can be just be interpreted as, you can put a squared for everything else. So this will be multiplied by sigma. I would get. So if we read this example, check example number 1. So we know CI as what? 95%. No? Then it says, suppose that she knows that the standard deviation of the time spent daily at the laboratory by all. You see this all. By all, it means that it's a population, like it is for everyone involved. So therefore, it's a population standard deviation. So this will be CI. Then sigma will be 7.25. How large a sample should the researcher select so that the estimate will be within? This within will always be a margin of error. What do we say is a margin of error? Remember, if it's within 2.5, it means that we are either minusing or adding 0.5. Always remember that. It's either we are minusing or adding 0.5 when we say within 2.5. So this will be E. So the good thing is that for 95, we know that, so copy those things so that you can tell them to me? Can you copy them? So CI is 95. And then sigma squared is sigma, not sigma squared is 7.25. Then E is equals to 2.5. So we know that, so we say example, it's example number what? Example 1, page 4. Example 1, page 4. We know that we're given CI is 95%, sigma 7.25, and then what is E?
2.5.
2.5. So then if that's the case, then now you just have to find the Z for 95. So I'm telling you that the answer for that will be 1.96. You go verify why it's 1.96. So N is supposed to be 1.96 multiplied by 7.25 over 2.5, everything squared. And that will be the answer. But you go verify why the answer is 1.96. So you will have to find alpha first. Alpha should be 0.05. And alpha divided by 2 should be 0.025. Then Z at 0.025 should be 1.96. But then you can go verify that. Any questions? Anything you didn't understand?
Hey,
Do you have to ask anything, ma'am?
say, how did you find 1.96?
You will have to go back to using the formula. Yeah. So we'll have to go back to that. We're looking for 0.25, 10 after the comma. Once you decide which rows are that, then after the comma, we want a row where there's a 2. After the 0, we want a row where there's a 2. That should be that row and that row. Then after the 2, want a 5. Want a row where after the 2, there's a 5. You only find it, where is it? Only in this row only, in 1.9. And then you find the exact value there. So we'll still be finding in the same way. You have the 0.025, go look for 0.025 inside. Then the same way. The rows way is there, like the rows with 10 after, and then we'll do that, and then we'll do that. Ngaledzani?
I want to talk about the poll. That's why.
The what?
The poll.
Okay.
I see majority of the people choose Tuesday from 3 to 4. And on Tuesday, we have commercial law at 3.
Up until what time?
Commercial a second year module, and also state is a
Up until
second year
what?
module. Up until, let me check. It's up until 4 teacher class.
How many people are doing commercial?
I'm not sure about that, but it's a second year module.
Okay, so for now we can keep the choosers the highest, but then we can try what we can do for the rest. So you won't be penalized for anything, but we'll try to see what we can do for the rest.
Okay.
Okay. And then Munyai?
Sir, can you please tell the tutor to repeat everything you did today? Because on my side, It take time what you are writing to reflect on my screen because of the network.
No problem. I will also send you the video to later on today.
Okay.
So don't worry, everything. So tutorials will start next week. So therefore, don't worry, we'll always try to have the best situations where we can try to get you to understand everything. So we have the physical, the online, and then we have the tutorials. The tutorials will be done for your liking for as many times as we want. But then this semester we'll have to enforce the tutorial sessions. We'll have to find a way to enforce them. I'm thinking maybe the quizzes can only be submitted during the tutorials, if you can do that. So we need to find a way where this class is 200 and something students, we can have tutorials with 50 students. But we'll find a way to enforce that. And then the second one is Mukumiseni, what? Mapon or something. What's your name? You can speak. Or junior spoken or Jubia Chirango, you can speak if I see your hand is up.
Sir,
Anyone with the hello?
about the poll, tourism students have a double class of a major. That
The
is
what?
started about the poll of the class that started at 3.
Okay.
Tourism we have a major that started at 2 and end at 10 to 4.
Okay. So it ends as 4. So I think we might just end up having it at 4. We might just have to choose 2 days. We have 4. We'll have a class at 4, and then we have another class at 4. Maybe 4 on Tuesday, and then we can choose another 4 another day. I think that would be the best. So we can do 4 on Tuesday and 4 on Friday. So no longer 3. So because I wanted 3 to 5, but then we can then just change it to 4 to 5, 4 to 5 on each day. Because it's going to be physical. Ma'am will be coming to teach you, I think, from next week or from the week after. So we need to have a class later on during the day. So it needs to be at 4 or at 3. So we can say, for now, we can agree Tuesday 4. So we can just go back to this. So for now, we can just say class timetable. Remember, we are keeping the online one that we already have now. The original timetable stays as it is. So now we can say Tuesday at 16:00, and then Friday, or Friday is too much. You don't want Friday, or Friday 16:00. So we can just do it 1 hour, 1 hour. Because all I need is 2 hours. Because I know that on Friday you said you have something at 3, so therefore it's ending at 4, so therefore we can have it at 4. And then another hands are up.
Sir,
Yes.
on Tuesday for tourism, we have a class for majors from 2:00 until 5.
Okay, so the thing
Even
is,
on Friday, we have a major
okay, so
at 5:00.
now that's why I gave you the permission. So communicate with the person who did the poll, with the tutor. Let's find the way that. So the thing is, this won't work for everyone. So we need to find a day that doesn't work for you. So let's say Tuesday that doesn't work for you, but Friday does. Remember, this thing will always be taught online. I'll be teaching everything online again. Everything that will be taught in person will also be taught online. So we just also need to have a class where if we need anything, we can know that we can do it on Thursday or on Friday. So let's just take this whole week, and then you can just decide. Maybe even Monday it's fine. I just need a day. I don't need a specific day. I just need a day where from 4 or from 3 we can have a class. I don't need a specific day. Any day that we have in mind, we can use it Monday to Friday. It's not like I'm saying it only has to happen on Tuesday or it only has to happen on Friday. So let's remove this so that you don't confuse those when I send this document. So just know. So let's have until the end of the week to go through it with the class with the tutor, and then we can find out what we can do. Anything else? If not, I'll see you tomorrow in class.